Have you ever wondered why an AI might confidently cite fake research or believe a false claim about cybersecurity? It's not just a glitch, it's a cognitive vulnerability. Like humans, AI models can fall for tricks, biases, and emotional manipulation. But how do we fix this? Today, we're diving into a groundbreaking study that redefines AI safety by treating these flaws like cybersecurity threats. Imagine a world where AI isn't just following rules, but thinking correctly. That's the goal of Cognitive Cybersecurity Suite, or CCS7. Researchers identified 7 ways AI models can go wrong, mirroring human cognitive weaknesses. Think of it as a checklist for the mind of an AI. Let's break it down. Take authority hallucination, when an AI makes up fake credentials or citations to sound smart. Or context poisoning, where repeated biased input slowly shifts the AI's perspective. These aren't random errors, they're systematic flaws in how AI processes information. To tackle this, the team ran a massive experiment. They tested 12,180 scenarios across 7 AI models, plus a human study with 151 participants. The key tool: a simple strategy called Think First, Verify Always TFVA. It's like teaching AI to pause, double-check facts, and avoid rushing to conclusions. Here's the twist: TFVA worked differently for different models. For some vulnerabilities, like identity confusion, it almost eliminated the problem. But for others, like source interference, it backfired, making errors worse. Meanwhile, humans improved by 7.9% on average. This shows something critical: AI safety isn't one size fits all. What works for one model might fail or even harm another. It's like a virus that affects different systems in unique ways. The takeaway: before deploying AI, we need to test its cognitive security, just as we test software for bugs. So what does this mean for the future? It means we're moving beyond surface-level fixes. By understanding these vulnerabilities, we can build smarter, safer AI, ones that don't just follow instructions but think like humans, but better. Stay curious and remember, the next time an AI seems off, it might not be a mistake. It could be a flaw we're still learning to fix. Thanks for watching, and let me know your thoughts below. Have you ever wondered how AI models make mistakes, and whether we can fix them? Today, we're diving into a groundbreaking study that reveals how different cognitive vulnerabilities in AI systems respond to simple fixes, and why some solutions can actually make things worse. Let's break it down. First, let's talk about identity confusion, a fancy way of saying AI models sometimes adopt the wrong role or perspective. But here's the good news. Researchers found that just telling models to state your true role almost completely eliminated this issue across all tested systems. One model even saw a 95% improvement. This shows that some AI errors are fixable with clear, straightforward instructions. But not all problems are so easy. Take source interference, when AI tries to verify conflicting information. The results: a major backfire. 6 out of 7 models ended up worse after being asked to fact-check, with one model, Mistral, seeing a 135% increase in errors. It's like giving a student a math problem they're not ready for. Their answers get more wrong, not less. Then there's context poisoning, where misleading information over time skews AI responses. Even with warnings, models like GPT showed almost no improvement. This suggests that some errors require deeper fixes, like changing how AI is trained or designed, rather than just tweaking prompts. And here's a twist: attention hijacking, when emotional language tricks AI into behaving differently. The results: a wild split. GPT barely changed, Kimi improved dramatically, but Mistral got worse. This highlights a key takeaway: there's no one-size-fits-all solution. What works for one AI might backfire in another. So what's the takeaway? The study identifies 3 patterns. First, specific instructions work best, like telling an AI to cite sources instead of vague warnings. Second, goal conflicts can cause backfire. If a prompt clashes with what the AI is trying to do, it can make errors worse. And third, deep-seated issues like context poisoning need more than just prompts. They demand architectural changes. The researchers even created a checklist for AI safety, rating each vulnerability's risk. For example, verify facts against context is a red flag for some models, while state your role is a low-risk fix. They also stress the need for cognitive penetration testing, a lightweight stress test to spot vulnerabilities before deployment. In the end, this study isn't just about fixing AI. It's about understanding that safety isn't a one-size-fits-all game. Some errors are easy to fix, others are tricky, and a few can even backfire. The key: tailoring solutions to the model, the task, and the risks. Imagine you're testing a car's safety in a lab. Just one crash test, one scenario. But real roads have unpredictable weather, other drivers, and sudden obstacles. That's kind of what we're dealing with in AI safety. Today, we're diving into a study that shows why lab experiments alone aren't enough, and why the cognitive risks of AI are more complex than they seem. See, most research looks at one vulnerability at a time, like testing a car's brakes in isolation. But real AI systems face multiple cognitive challenges at once. Think of it like a driver juggling navigation, traffic, and a sudden storm. This study reveals that when you test just one flaw, you might miss how interactions between different cognitive errors can create bigger risks. It's like discovering a car's weak spot only in perfect conditions, but not when it's swerving to avoid a deer. The team ran 12,180 experiments across 7 major AI models, and here's what they found. Some models had systematic vulnerabilities, like human biases, while others worse when we tried to fix them. For example, one model's error rate jumped 135% when researchers tried to block a specific flaw. That's not a glitch, it's a backfire. It's like trying to fix a car's brake problem by adding more weight, which makes the whole system less safe. Check out this heat map. Blue means the model handled risks well, red means things got worse. Notice how some top models like GPT-4 and Claude Sonnet stayed strong, but others like Llama and Mistral suffered when we applied fixes. It's a wake-up call. One-size-fits-all safety measures won't work. Just like you wouldn't use the same seatbelt for a sports car and a delivery truck, AI needs architecture-aware solutions. So what's next? The researchers are pushing for 5 big ideas. 1. Expand safety nets beyond current methods to tackle new, unknown flaws. 2. Discover more vulnerabilities as AI gets more complex, like mapping uncharted roads. 3. Understand why some models fail by peeking into their mind with advanced tools. 4. Create smart, adaptive rules that change based on the AI's structure, like a GPS that adjusts to traffic. 5. Build universal safety tests so we can compare AI systems fairly, not just by speed or accuracy. This isn't just about fixing bugs, it's about rethinking AI safety from the ground up. The study's authors call this cognitive cybersecurity, a new field that protects the thinking behind AI. The takeaway: the future of AI isn't just about power or speed. It's about resilience, adaptability, and understanding that some flaws aren't just errors. They're lessons in how to build better systems. Stay curious and remember, the next time an AI seems off, it might not be a mistake. It could be a flaw we're still learning to fix. Thanks for watching, and let me know your thoughts below.